Using the standard long division algorithm, divide the quartic function f of x equals x to the fourth plus 3x cubed minus 6x minus 3 by the quadratic function g of x equals x squared minus 2. If possible, express the quotient h of x as a polynomial function. Okay, so we're going to be using long division here. Let's go ahead and set up our long division, putting the f of x function underneath the division sign as the dividend, and then we'll put x squared minus 2, the divisor, on the outside. So I'm going to stop here. When putting the dividend, then we see that we have x to the fourth, x to the third, and notice we don't have an x squared term, and we do need to put a placeholder for this with our division, and so we can just put a 0 there, and then we can keep going in order since then we have an x, and then we have a number without x on the end. And so now we can go ahead and start a division. So we need to first think x squared times what will give us x to the fourth. You can almost think of it as a little circle. So x squared and then times whatever's here needs to equal x to the fourth. So x squared times x squared equals x to the fourth. So now we can go ahead and take that and multiply it out by x squared minus 2. So x squared times x squared is x to the fourth. X squared times negative 2 is minus 2x squared. So here we have x to the fourth minus x to the fourth, which is just 0. And then notice we have 3x cubed minus negative 2x squared. Well, those are not the same like terms here. We have an x cubed and x squared, so we can't combine them. So we'll still just have our positive 3x cubed, and then we can just put right to the next to it, well, minus negative 2x squared. We can just put plus 2x squared. And we might, we'd normally bring down this 0, but since it's just 0, 0 plus 2x squared is still 2x squared. So we can just leave it as so and repeat the next step. So what times x squared gives us 3x cubed? We've got this coefficient that we need to multiply by, so 3, and then we'll need another x to get the multiplied by to the 3x cubed. So then 3x times x squared gives us 3x cubed, as we expected, and then 3x times negative 2 gives us negative 6x. And then notice that we have the same thing here with x squared and the 6x not matching, so I'm just going to write the minus 6x over here in the next placeholder. And we'll go ahead and minus that. So we have 3x cubed minus 3x cubed, that's just 0. 2x squared minus nothing with an x squared term there, that's just 2x squared. And then we can even just bring down our next negative 6x and combine it with what we just had multiplied out. So negative 6x minus negative 6x is just plus 6x. So that will just be plus 0. And we don't even have to put that, it'll just add to 0. And then let's go ahead and bring down our last term there. And so then now, multiplying this out, then what times x squared gives us 2x squared? We just need to multiply by that too. So multiplying it out now, 2 times x squared gives us 2x squared. 2 times negative 2 gives us negative 4. So we can just write that over here. So then we'll have 2x squared minus 2x squared gives us 0, and then negative 3 minus negative 4, that's plus 4, gives us positive 1. So we do have a remainder here of 1, and so the way that we could write that is just plus 1 and then over our divisor, x squared minus 2. And because we have that remainder, then h of x, the quotient there, will not be a polynomial function, but we can express it as a rational function, which would just be h of x equals x squared plus 3x plus 2 plus 1 divided by x squared minus 2. So let's go ahead and summarize our answer. Since there is a remainder, the quotient cannot be expressed as a polynomial function. However, it can be expressed as the rational function h of x equals x squared plus 3x plus 2 plus 1 divided by x squared minus 2.